Hello dear friends, it is said that the most important quality you need in coding is the ability to think ahead. Well yes, maybe it's not the most important ability, but it is very important. It saves a huge amount of time. We will adjust the rule a bit in our lessons. Clashing with unforeseen is also a part of programmers' work, and we must learn to deal with issues we couldn't predetermine. Maybe that's why we love programming so much. Before we dive into the movement topic, we need to discuss some points regarding the update function and time control in Unity. Let's get started. I will start by completing the topic of the previous video. Let me run the play mode and click on a hex. I noticed that when displaying the optimal path, we lose a target hex frame. It becomes white instead of staying green. Well, it happens because inside the neighbors finder scripts we have getAdjacentHexes method that calls makeMeAvailable method. The method sets a white frame to the current state object. This wasn't a problem until we added positionForPath class to the structure. The positionForPath class also calls the getAdjacentHexes method and, as a result, calls makeMeAvailable method. Well, it's easy to fix. The structure we created allows us to individualize class behaviors, so I will cut the makeMeAvailable method call, then paste it inside the positionsForFlying class. I will not refer to the field manager class, I will refer to the hex variable instead. I will do the same for the positionsForGround class. The positionForPath class has a different behavior, it doesn't call the makeMeAvailable method, so I will leave it unchanged. Let me run the play mode. Now everything is alright. We haven't yet determined the possible positions for ground regiments, but soon we'll return to this issue. In the meantime, let's teach a hero to move. We have different options to move objects in the scene. Some of them require a rigid body component, for example, rigid body set velocity, rigid body move position, or rigid body add force. Some of the movement methods do not need to have other components, but transform component. Rect transform component inherits from a transform component. So all that I say in this video about the transform components will be true for the rect transform component. Therefore, in this video, we will ignore the difference between the two components. But this is not always true, since rect transform component has its extensions. Let's move on. We're not going to go through all these methods, since we don't have a rigid body component in our game. However, we will apply methods based on transform component. Our game does not require complex solutions regarding the movement of heroes, but requires a lot of knowledge. Therefore, the first thing we will do is discuss some theoretical aspects of movement in Unity 3D. The idea is very simple. Each object has a transform component. The transform component determines the position, rotation, and scale of each object in the scene. Position property determines the position of the object in x, y, and z coordinates. The position, rotation, and scale values of a transform are measured relative to the transform's parent. If the transform has no parent, the properties are measured in world space. To move an object from one point to another, it is enough to change the coordinates of the object using the code. Since this is about components of the object, we may access all its properties via script. Coordinates of the object may be represented as a vector. We remember that a three-dimensional vector is represented as the values of three coordinates along the x, y, and z axis. These coordinates are determined in the transform component. To represent the 3D vectors and points, we use a magic word vector3. Vector3 is not a class, it is a structure, but you don't need to focus on the structures now. All we need now is to learn how to use this tool. Let us move our hero in any direction. We have a hero script and the awake function. When I select a hero object in Unity, Inspector displays the coordinates relative to the parent object. If I write word transform here, I will refer to the transform component attached to this game object. MonoBehavior class inherits the transform member from one of the parent classes. And this property has the appropriate access modifier, so we can use it here without a declaration. we got the reference to the transform component and to the transform class. Now, to get access to the position variable, I will write position word and create new coordinates. So new, vector free, and I need to write parameters here. Parameters determines x, y, and z coordinates of the object. If I write 0 for all of the parameters, I will move a hero to the center of the world space. Let's check the statement. Before I run the Unity, I will adjust the value of the order in layer property. Let it be equal to 3. Now, just remember that order in layer property allows us to determine the render order of sprites in a scene. In particular, this allows us to display the archangel closer to the camera than the landscape image of the BattleHex object. And yes, when I start the game, the position of hero is changed. It's important to remember that using the transform position will locate the game object in the 3D world space. In doing so, we ignore the relationship with the parent object. If I select the fairy object in the play mode, I will see its coordinates relative to the parent object. Global coordinates of a hero object are all zeros now. However, its local coordinates show the distance from the parent object. If I change the coordinates immediately, then the object will disappear in one place and appear in another. Since this happens instantly, we will not get the effect of the movement. We get the effect of playing the stock market. Here you are rich, and you become a beggar in one moment. We don't want this to happen, we want to move the object towards the target smoothly. In this case, we'll use the update function and move towards method. Let's discuss move towards method first. It is a method that belongs to the vector-free class, and its syntax looks like this. We need to have coordinates of the position to move from, coordinates of the position to move towards, and distance to move each time we call the method. Instead of the current position, I will write a transform position. Instead of the target position, I will write new, vector-free, with the same coordinates. And for the distance, let me write a number of float type. Now, if I press the play button, I will see that the hero has moved. A hero moved too fast, but this time the move wasn't instant. Every frame a hero moves to a distance determined by the float variable. A hero moves along the vector, which we determined using the current and target points. We haven't animated the flight yet, and actually the direction of movement is wrong. However, we took the most important step to achieve the goal. Now we need to go deeper into the understanding of update function. I said that the update function is called once every frame. So what is a frame in Unity? A frame is a screen update. So when I say that function is called every frame, I mean that when your mobile or PC updates the screen, then the function is called. Obviously, every computer or mobile phone has its own limits. For example, computer A displays 50 frames per second. Then we say that its FPS is equal to 50 at the moment. Computer B has 25 FPS. It means that it displays 25 frames per second. Therefore, the object will move 50 times the value of the distance per second variable if I use a computer A, and 25 the value of the distance per second variable if I use a computer B. In this case, you can forget about multiplayer games. Time deltaTime comes to save all the players in the world. So time is a class, and deltaTime is a variable of that class. DeltaTime provides the time between the current and previous frames, so it is the amount of time taken to render the last frame. If FPS is equal to 50, then DeltaTime is equal to 200th. If FPS is equal to 25, then time DeltaTime is equal to 400th. This is just simple math. And how can we use that? Let me declare a variable and call it distance per second. Assign a value to the variable and replace the float in the parameters of the move towards method. We'll multiply the value of distance per second variable by time deltaTime. Let's see how this will help us to balance the gameplay. Let me adjust the value of distance per second variable and let it be equal to 5 now. Multiply it by time delta time and you will get 1/10. We do this calculation each frame. So each frame, to get the needed distance per second, we move the object by 1/10 of a unit. Since we have 50 frames per second, finally we will move a hero by 5 units each second. The same calculations can be done for the computer B. We want to move a hero by 5 units per second, so the result of multiplication here is 2/10. So each frame we move a hero by 2/10 of a unit, but we have 25 frames per second in this case. Multiply by a number of frames per second and we will get 5 units per second. The same result for both of the computers. Well, the idea was very simple. When you multiply with a time delta time, you essentially express, I want to move this object 5 units per second instead of 5 units per frame. You just forget about frame rate and recalculate movement depending on a second. That has the same meaning for all of us. Now let's see the difference between the option we have used before and using the time delta time variable. First, I will run the code with the time delta time variable. It goes slowly. If I delete the multiplication, I will get another result. Let's press the play button. And a hero moves very fast. Well, I hope it's clear why it happens. If we don't use time delta time, we move a hero every frame. It is faster than if we move a hero each second by the same distance. We'll teach a hero to move along the hexes in the upcoming video. It's going to be very interesting.